Oh, what a day! What a lovely day!
Welcome to Science versus Scientism. I'm your host, Nathan Oakley, and joining me this evening is John, otherwise known as YouTuber Quantum Eraser. How you doing, John? Good to have you.
Hey, Nathan, thanks for having me.
Pleasure, as always. I understand you want to launch straight into ripping gravity a new one and educating people in the ways of science. So let me know when you're ready and you can launch straight into it.
I'm ready. Is my screen up?
We'll be in about 5 seconds. Yep,
Okay.
You're up.
So before we get into this, I noticed personally a quite substantial uptick in the vitriol and negative waves from the ball embracers in my general direction. The ball huggers have now shifted their focus from the Wiki Road Scholarship to my mom, my alma mater, and my breeding potential. I don't know, but I think I have the cure for what ails this. And maybe it'll cheer them up and calm the waters. We'll talk about science. How about that? All
Sounds
right.
good.
The queen of science. Experiment. This is real easy. From the University of Rochester, Physics Department, the scientific method distinguishes science from other forms of explanation because of its requirement for systematic experimentation. That means if you don't have an experiment, you don't have science. From Introduction to Theory and Application of Molecular and Quantum Mechanics, the final arbiter of truth in science is experiment. From the Chair of Physics at Yale, Professor Shankar, the only way things change in physics is experiments. Everything is based on experiment. That's the only way we change our mind. From Richard Feynman, if it doesn't agree with experiment, it's wrong. And that simple statement is the key to science. I think we're getting the message here. Let's do a couple more. From Max Planck, experiment is the only means of knowledge at our disposal. Everything else is poetry, imagination. And finally, again from the physics department at the University of Rochester, the scientific method requires that a hypothesis be ruled out or modified if its predictions are clearly and repeatedly incompatible with experimental tests. Further, no matter how elegant a theory is, its predictions must agree with experimental results if we are to believe that it is a valid description of nature. In physics, as in every experimental science, experiment is supreme, and experimental verification of hypothetical predictions is absolutely necessary. So there should be no questions here. If you're going to make a claim and it's scientific evidence, you got to have an experiment. So what's an experiment? Well, it's a hypothesis test. The hypothesis is actualized. So a scientific hypothesis. A scientific hypothesis is your experiment statement. I know, shocking surprise. It expresses a testable proposed cause and effect relationship, the phenomena that was observed in step one. It's a classic if this, then that motif. However, not every if and then statement is a hypothesis. Let me make that clear. From the physics department again, from the University of Rochester, the scientific method requires that a hypothesis be ruled out or modified if its predictions are clearly and repeatedly incompatible with experimental tests. You see this predictions over here? This is a scientific prediction. It's not a Gene Dixon, Edgar Casey, carnival tent prediction. This is a scientific prediction. Every scientific prediction must have one of these. From Nature, California Institute of Technology physicist Sean Carroll arguing in The Edge that hypotheses aren't simply useful tools in some potential outmoded vision of science. They are the whole point. A scientific hypothesis is based on cause and effect. Reasoning. A scientific hypothesis does not merely state X and Y may be related, but explains why they are related. That's from Lowell C., Becoming a Successful Scientist, from Cambridge. From Drexel University, the scientific method is hypothesis-driven. One makes an educated guess to explain a cause and effect relationship. From the University of North Carolina, an independent variable is the presumed cause, whereas the dependent variable is the presumed effect. The IV is the antecedent, whereas the dependent variable is the consequent. From California State, scientific hypothesis, a special kind of prediction, there's that word again, right? That forecasts how the independent variable will affect the dependent variable. From California State, formalized hypotheses contain two variables. One is the independent, the other is the dependent. Hopefully that's clear. Independent variables. In an experiment, the independent variable is the variable that is varied or manipulated by the researcher, and the dependent variable is the response that is measured. Again, an independent variable is the presumed cause, whereas the dependent variable is the presumed effect. The IV is the antecedent, whereas the DV is the consequent. From Penn State, the independent variable. It is what is varied during the experiment. It is what the investigator thinks will affect the dependent variable. From Colorado State, the independent manipulated variable is the variable changed by the scientist, what the investigator is testing. From Physics About, the two main variables in an experiment are the independent and dependent variable. An independent variable is the variable that is changed or controlled in a scientific experiment to test the effects on the dependent variable. So, they're all on the same sheet of music. They're all saying the same thing. So, a viable independent variable must satisfy two criterion. Number one, it's the presumed cause, but it's not a presumption in and of itself. For example, vitamin C or insulin. We're not presuming them. They exist. Number two, it is what is varied and manipulated in an experiment to test its effect on the dependent variable. So let's pick out the viable independent variables here, and we can just use one of these conditions, or both, or any of them. I'll just pick varied and manipulated. So insulin and vitamin C, can we vary and manipulate those? Yeah. The ball Earth. Can we vary and manipulate the ball Earth? No. Heat. Can we vary and manipulate heat? Yeah. Can we vary and manipulate the sun? No. Can we vary and manipulate light? Yeah. Can we vary and manipulate Mars? No. Can we vary and manipulate time? And that's not stopping your watch or a clock. The clock is not time. And can time be a cause? Does time cause the sun to rise? Does time cause the difference of scores between the first and third quarters? I don't think so. So, and where do we get scientific hypotheses from? Well, step one of the scientific method, observation of a natural phenomenon. So let's go through an example. So let's observe a phenomenon. Healthy type 1 diabetics suffer from diabetic ketoacidosis, apparently from the absence of adequate insulin. So the alternative hypothesis, given otherwise healthy type 1 diabetes patients, the lack of insulin will lead to diabetic ketoacidosis. The null hypothesis, given otherwise healthy type 1 diabetes patients, the lack of insulin will not lead to diabetic ketoacidosis. So the independent variable here is insulin, or the lack of. It can be manipulated. And the dependent variable, the effect or the prediction, is diabetic ketoacidosis. This is a viable scientific inquiry. Both hypotheses are viable, and so are the independent and dependent variables. Now, I want to stop here for a minute. and take a look at this alternative and the null. Is there any similarities between these two guys? Right? It looks like they're mirror images, save for the fact that the alternative is will and the null is will not, correct? They are mirror images. That's what these guys need to be. The wiki parroters out there, you know, we've been hearing it. I don't know where they got this from, other than wiki, that science can't prove anything. It can only disprove, right? Well, they're clumsily attempting to parrot without any background whatsoever, which is hilarious, by the way. The goal of every single scientific inquiry is to reject or falsify this guy, the null hypothesis. Okay? How do we do that? Well, we confirm or validate the alternative hypothesis, right? These two are the antithesis of each other. So if we test the alternative hypothesis, that gives us the answer as to whether we can keep the null or it's rejected and falsified. I hope that's clear to everyone. In conclusion, the null hypothesis or the zero difference hypothesis from California State. To do a hypothesis test that's an experiment, you will actually have two hypotheses, the null hypothesis and the alternative hypothesis, which are stated in such a way that they are mutually exclusive. You can't have both hypotheses be true. The null hypothesis is the conclusion that is considered the default. That is, you will accept this hypothesis if you fail to find sufficient support for the alternative hypothesis. So we're going to accept this if we fail to find sufficient support for this guy. Hopefully that's clear. When you prove this, you ipso facto reject or falsify the null. It's just that simple. So, experiment. What's an experiment? From Penn State, there should be 3 categories of variables in every experiment: the dependent, the independent, and the controlled. The independent variable, the cause, that which is varied and manipulated. Remember, it has 2 requirements. It's varied or manipulated by the scientist to produce the effect. The dependent variable is the effect, the result, or your prediction. And the controlled variables, variables that are held constant so as not to confound the test. You don't want anything in there confounding your results. From explorable.com, experimentation. There are 3 important variables you have to remember when you're designing your experiment: the independent, the dependent, and the controlled variables, right? Pretty much lining up. Let's go to Wiki. Let's see what Wiki has to say about this. The Wiki experiment. An experiment is a procedure carried out to support, refute, or validate a hypothesis. Experiments provide insight into cause and effect by demonstrating what outcome occurs when a particular factor is manipulated. So I want everyone to take a wild guess what that factor being manipulated is. It's the independent variable, like we just went over 25 times. So in conclusion, I'm going to leave this up for a couple minutes. In conclusion, the alternative hypothesis, this is how you differentiate between these guys. The alternative hypothesis is independent variable plus your dependent variable, that's the cause and the effect, equals a prediction of cause and effect. The null hypothesis is the independent variable plus the dependent variable equals prediction of no cause and effect. The zero difference, the null, no. And the experiment is the independent variable plus the dependent variable plus what? The controlled variables equals prediction of cause and effect. Hopefully this is getting through and this is clear. So there won't be too much more confusion over this. All right, science. The intellectual and practical activity encompassing the systematic study of the structure and behavior of the physical and natural world through observation and experiment. So, what's the natural world? All of the animals, plants, and other things existing in nature and not made or caused by people. What's the physical? Well, of, relating to, or resembling material things or nature, the physical universe. So, the definition of physics from physics.org. The dictionary definition of physics is the study of matter, energy, and the interaction between them. But what that really means is that physics is about asking fundamental questions and trying to answer them by observing and experimenting. So physicists ask really big questions, which is ironic because most of these are not scientific inquiries. How did the universe begin? How will the universe change in the future? How does the sun keep on shining? And what are basic building blocks of matter? Yeah, they're going to have to take a re-look at those. So if something's natural and physical, it must have either chemical formula or structure, charge, mass, momentum or spin, or kcals, kilojoules, or millielectron volts, folks. If it's material, natural and physical, it must satisfy either one of these, at least. So show us either of these for a vacuum, right? Because this was a subject that was brought up this week. Show us one of those when a vacuum is defined as, even from Wiki, vacuum is a space devoid of matter. So let's look at the definition of physics again. It's a study of matter, energy, and the interaction between them. So how in the world can physicists study matter and energy without matter and energy? A vacuum. It's devoid of matter. Again, science, the intellectual and practical activity encompassing the study of the structure and behavior of the physical and natural world through observation and experiment. It says physical and natural world to carefully delineate the physical and natural, that's light, helium, nitrogen, oxygen, lightning, tornadoes, electrons, protons, neutrons, etc., from the physical non-natural, that is lawnmowers, computer desks, vacuum chambers, 5-speed transmissions, chicken coops, steel-belted radials. Okay? This is not a natural phenomenon like all the others. And this should drive home the point from Kennesaw State. A law describes what nature does, as opposed to a theory explained how nature works. So, are these guys talking about the toaster oven laws or the lawnmower theories? I don't think so. Now, on to scientific theories and scientific laws. Before we start into the scientific theories, I hope everyone's aware that there's a difference between scientific theories and the colloquial theory. The colloquial theory is abject speculation. Well, I have a theory on this and this and this. No, you have a speculation on it. It's probably best to use that word because as soon as you say theory, people all of a sudden, relate scientific theory when most people don't know what that is either, but you know what I'm saying. So scientific theories, everything in science is defined precisely. They have a precise meaning. Scientific theories explain the how and the why, the mechanism and the process, and identify the cause, right? Uh-oh, boy, that sounds like a hypothesis, doesn't it? The how and the why and identify the cause, that's like germ theory, right? Yeah, because scientific theories are the result of validated, confirmed scientific hypotheses that have been rigorously tested. That's why they sound like them. As opposed to scientific laws, they only describe. There's a difference between explanations and descriptions. And the difference is explanations answer how, why questions. Descriptions answer what is question. So, for laws, the how and why and the cause is not applicable. They are based solely on observations, often expressed mathematically, because mathematics are descriptions. For example, the second law of thermodynamics. That's why they're called the laws of thermodynamics and not the theories of thermodynamics. There's a reason for that. And a scientific law never becomes a scientific theory or vice versa because they each deal with different questions and both are in two different domains. Again, from Kennesaw State, a law describes what nature does, and a theory explains how nature works. From this view, laws and theories do different things and have different roles to play in science. And remember from our last discussion about scientific laws or physical laws, right? They're not actually scientific. It's a misnomer because no scientific law ever enters the scientific method. It can't enter it. You can't ask a cause and effect question on a scientific law. And I'd use the laws of entropy. We only know that they exist. We don't know the cause of why heat flows from hot to cold or energy from concentrated to dispersed always. We don't know the cause of that. It just does. Okay, that's the science review. Now back to gravity. This is starting to come up again. I don't know for what reason, but let's go over it again. Gravity. Any moron knows that if you drop an anvil from elevation, that it's going to fall to the ground. Conjuring a word that describes the action, gravity, or ducal slope regards, or whatever, I can just make up a term, doesn't validate that it's the cause. It's just a description. However, this is very important. When somebody states gravity in our common vernacular, they are immediately invoking a cause, whether they like it or not. It's either mass attracting mass, that's Cavendish or Newtonian gravity, or space-time, and that's Einsteinian. So Cavendish or Newtonian gravity is a force, whereas Einsteinian gravity is not a force. There's a big difference here, folks. From Caltech, Einstein came up with the theory of general relativity in 1915, the prototype of all modern gravitational theories. Its crucial ingredient, involving a colossal intellectual jump, is the concept of gravitation not as a force. Let's all sing this together. Not as a force, but as a manifestation of the curvature of space-time. These guys are not even in the same geometry. Newtonian or Cavendish gravity is in Euclidean 3 space, whereas Einsteinian gravity is in pseudo-Riemannian 4 space. They are clearly mutually exclusive. So one or the other, you can't be both. So as I said, well, Newton proposed, well, he proposed an equation. Well, this is just a description, right? That's all it is. It doesn't give any explanations. However, okay, let's take a look at these. Newton proposed this equation. However, Cavendish proposed this 100 years later. Now, can you take a look at these? Are these different? I'm thinking so. Newton himself wasn't exactly married to the idea. In a letter to Dr. Richard Bentley on February 25th, 1692, Isaac Newton says, "'Tis inconceivable that an inanimate, brute matter should, without mediation of something else, which is not material, operate upon and affect other matter without mutual contact. That gravity should be innate, inherent, and essential to matter, so that one body can act upon another at a distance through a vacuum without mediation of anything else, by and through which their action or force may be conveyed from one to another, is to me so great an absurdity that I believe no man who has in philosophical matters a competent faculty of thinking can ever fall into. In other words, Sir Isaac Newton believes that if you believe in gravity, that you should be institutionalized. Okay, that's pretty clear here. So let's end this Newtonian Cavendish gravity buffoonery quick. So the scientific community, whoever or wherever they are, we have some questions for them, by the way, doesn't follow Newtonian gravity. From George Musser, Scientific American, Einstein created his general theory of relativity, which provides our modern understanding of gravity, with the express purpose of expunging non-locality from physics. Isaac Newton's gravity acted at a distance as if by magic, and general relativity snapped the wand in two by showing that the curvature of space-time and not an invisible force gives rise to gravitational attraction. What are they talking about here? Not an invisible force. What's the juxtaposition? Well, the juxtaposition is between Newtonian gravity and Einsteinian gravity. Is this clear? So, bye-bye Newton and Cavendish. So, now to Einstein. So relativity, that is special relativity and general relativity for gravity in this specific case, but I figured I'd take them both to the woodshed while I was here. Now remember, special relativity and general relativity are not actual scientific theories. They don't follow the scientific method. So, relativity, special relativity and general relativity via different mechanisms, speed versus gravity, can dilate, bend, or warp time. Here's the primary school falsification. I don't even need to get into quantum mechanics falsification. I can stop right here. It's overkill after this. So, time is a conceptual relationship between two motions. Specifically, it's based on alleged single rotation of the Earth on its axis in respect to the sun, a day. It's a concept. It's non-physical. Time is without chemical formula, structure, dimensionality, orthogonality, direction, or location. You can't put some time in a jar and paint it red. I mean, come on now, let's reason together. Can you dilate, bend, or warp non-physical concepts? If you can do this, you need to change your vocation to carnival. Is it your contention that if you have poison ivy on the brain, you can scratch it by thinking of sandpaper? I mean, freedom is a concept too. Can you bend that? Moreover, that which you are using to measure isn't the thing that you're measuring. For example, a football field is 100 yards long, but a football field isn't yardsticks. If I bend a yardstick, does the football field bend also? So if something, say, affects its cesium atomic clocks, or any modern clock for that matter, does that ipso facto mean the Earth's alleged rotation in relation to the sun is affected? These two mytho-mathematical fairy tales, special relativity and general relativity, were falsified 30 seconds after their respective publications by third graders at recess. Each in total, at best, at the very best, are massive reification fallacies on nuclear steroids. So, let's put the final death knell into this, and I'm sure everyone's going to be able to see this relatively quickly. So, Martin Rees, astronomer royale with cheese, esteemed British cosmologist and astrophysicist. What causes gravity and mass? These questions still baffle all of us. What? And we have everyone appealing to Newtonian or Einsteinian or combinations thereof? Why? According to Professor Rees, does mass attracting mass cause gravity? No, he's still baffled. According to Professor Rees, does space-time cause gravity? Nope. So why are we hearing this term gravity? Everyone appeals to it. Why? Can somebody tell me why? Therefore, gravity is merely a conjured term that describes an effect. It's not a cause. Thank you very much. Have a nice day.
Absolutely awesome. Is that genuinely the end of the presentation?
That is genuinely the end. What more do I need?
That's a recap. I mean, you've done this with cathexis, but
Yep.
slightly altered, not exactly the same, but pretty much the same.
Well, we got into more detail. I not only provided the primary school falsification, I went into the quantum mechanics falsification, but I don't need to do that here. I don't need to do that. We'll talk about quantum mechanics coming up. We'll get to him in a few weeks.
Sure. I mean, I just appreciate the fact that you're going over the same stuff because it needs reiteration for it to sink into a lot of people's mind. And it's nice to see people like Dan Pratt out there talking about the scientific method right here, right now, and others joining the panel on the debates and actually, employing it, using it to destroy ballers. I mean, I will keep this relatively short and sweet, John, but one thing I will say is the irony level is just upped by 1,000% recently because we are called science deniers. And we're not. We're pseudoscience deniers, as you put so eloquently.
Exactly. It's flipping it on its head because what have we been told for the past 3 years? If you believe in the flat earth, you must deny all of science and all of physics. And you're religious, you flat earthers. But what is it actually? It's a complete flip. It's a reversal. They're the religious zealots and the religion believers, and they must deny science, the scientific method. How ironic.
Yeah, exactly. The irony that the undoing of the globe, which has apparently got the entire body of science behind it, is the scientific method. Just pure irony.
It certainly is, sir. And a lot of people are seeing it now. And I think and like you said, repetition is so important. It may seem redundant, but I think it's really important for people to understand this stuff because most people, your average Joe Coffey and Betty Breadmaker, they haven't been in school for a long time, right? Or if they did any schooling, it didn't go past high school. Nothing wrong with that. And they forget what science actually is. And it's not hard. I mean, it doesn't take a rocket scientist, just launch pad security, to figure out what the scientific method is. It's quite simple. And it's simple for a reason, right? Anyone can do it. Anyone can do it.
And another thing that's just crossed my mind since you said was a point that Numinum brought up, which is that it has limitations, but those limitations are there for a good reason.
The limitations of the scientific method is cause and effect. If it's not a cause and effect question, it's not a scientific question, right?
Well,
There's
maybe
other ways.
I was just going to say, maybe I can parrot a question that was asked to you by Philip, who's studying to be a PhD, as I understand it. He said, well, what happens if you've got more than one variable? What do you do then?
It's not science. If you can't isolate your independent variable, you don't know that variable is causing the effect. You follow? You can never pin it down.
Simple stuff. That's why I like it. I'm not the smartest guy in the world, but I can get it easily and employ it and use it. And people who I previously considered my intellectual superior, ultimately speaking, are undone by this scientific method when applied to any of their baller proofs. All of them are based on models and presuppositions. It never changes. And another phrase you've used, which is rinse and repeat. We're going through this process, and you will see it, although I'm starting to call people on it, the process of asserting something, having it be debunked or picked apart very slowly in the debate process, and then they reassert it right after, just exactly the same, like we've not gone through any of it. It's an amazing process that they go through.
It happened today. Yesterday, somebody brought up, differing weights at the equator and the North Pole, and we demolished it because it was easy to, because there's nothing there. There's nothing scientific there. And then I turned it on this morning. I woke up late. I turned it on this morning, and guess what I hear? It's the same person bringing up the same argument. I'm like, wait a second.
Yeah, Lewis Hackett brought up the exact same argument after being taken through the steps of the scientific method and showing him why it didn't have any of the requirements covered. He had the observation covered. That was it. The observing a phenomenon. That was it. That's all he had covered. From there on in, his hypothesis fell apart, and it was loosely explained to him on the spot, but none of it sunk in. Not that, like I say, the reason I'm pleased this is happening is because it's not necessarily going to sink into anybody's mind unless they hear it repeated and get familiar with the process being employed, and hopefully that's being seen on the debates. People actually seeing how you undo most of the ball earth arguments, most if not all, are based on the presupposition that you're on a ball.
Yes, and like I said before, every single scientific proof, in quotes, from the spinning ballers is an affirming the consequent form of logical fallacy. Now, I didn't go over that in here. I'm going to save that maybe for a different presentation. But every single one is just like that. And remember, observing phenomena is only the first step of the scientific method. I mean, everyone can observe phenomena. That's fine. We're good to go. Yeah, you can pass that step. The problem comes in when you get to step 3. Construct the hypothesis. See, that's where it stops, because if it's something that you can't get a hold of, that you can't vary and manipulate, that you can't confirm that it's the cause of your predicted effect, then it's over right there. It stops. You stop at the scientific. You can't get to an experiment. It's over.
Yeah, it's all about the if and then relationship, the cause and effect, the independent and the dependent variable. And the independent variable in many instances is things like Earth's sphericity or Earth's turning. And you go, well, you can't get hold of those things, as you put it. You can't manipulate them. They can't be an independent variable. It's as simple as that.
Yeah, it's as simple as that, because you can't isolate it, then validate it that it's your cause. See, all they're doing is, like I said, affirming the consequent form of logical fallacy, because you can't test or confirm anything. All they're doing is giving an observation of a phenomenon and a just so story explanation. No test, no nothing. It stops right there. Observe a phenomenon, give you a story, right? And then ask you for your story. Well, I don't have a story, and I don't need a replacement story to pummel your fairy tale story. So I don't know. That's all it is. It's nonsense. I'm sorry. It's what it is. It's nonsense.
Yeah. Again, you summed up something that Numi said on the show earlier today, which is to say the most scientific answer, if you don't know something, is to say that you don't know, rather than just make up a just so story and tie that in with an observation. Just before we do end, though, John, can you round out maybe by saying the difference between an observation and observation of a phenomena?
Yeah, an observation. Now, anyone can make an observation. There is no scientific observation, by the way. I mean, the scientists don't have different eyes. They're not calibrated, right? We all have eyes. So scientific observation and observations are observations. Okay? Now, the difference between observation and observing a phenomena is, like I said, there's a tree out in my backyard. If I look out my back window, there's a tree out there. That's a concrete noun. I can't ask any more questions about that, because I wasn't here when it was planted. I just see a tree out there, right? I can't ask any questions. Now, if there's leaves falling off it, that's a phenomenon. I can ask a cause and effect question about that, right? Because that's a phenomenon. It's not a concrete noun. You can't look at a tree and then come up with a hypothesis, because it's inane. There's nothing there. There's no meat on the bone there. Even though we know how trees are created, in a vacuum, for the lack of a better term. I just can't look at something and it's a concrete noun, there's no phenomena, and come up with a hypothesis. I can't do it. It's not conjure a phenomenon from a concrete noun. It's observe a phenomenon. And more importantly, from Niels Bohr, said that a phenomenon isn't a phenomenon unless it's an observed phenomenon. And that gets into quantum mechanics, because if you don't observe it, then you're out of luck. And like I said, we'll get to that here in a week or two. And hopefully people understand it.
Excellent. Was there anything else you wanted to add before we round out proper?
No, that's good. I think this was a good presentation. It was short, concise, to the point. Hopefully people will come back to it and just review it. Maybe practice a couple hypotheses, what they think are hypotheses, and just try to apply it themselves, right?
Yeah, we had exactly that earlier today with Arwin. So he tried to formulate it, he failed miserably, but ultimately you've got to try and you've got to fail in order to succeed eventually. So hopefully people will do exactly that and pick up on some of the stuff that you're putting out there, John. And ignore the ridicule, as you started off the show by saying that you've received a lot. All it means is you're close to the target if you're getting a lot of flack. So I'm almost pleased to hear it, not quite. But with that, I will say a massive thank you to you, John. Pleasure to have you.
Thank you, sir.
And also, I will say a massive, huge, enormous thank you to all of the live audience for tuning in and hopefully for sharing this show. If you've not done so already, be sure to like, comment, share, and subscribe. I've been Nathan Oakley, and I will see you all in the next video.
Oh, what a day! What a lovely day!